I'm going to go to the Japanese and with Matthew.
Okay. So anyway, quadratics are important. We're going to be using quadratics in real life. Anybody who might be thinking about engineering or anything with physics, you definitely want to know this. Anybody take calculus later on? We're going to be using a lot of this. So it's good, and it's all good stuff. Now, to kind of broaden this a little bit, quadratic functions are members of the conic section. Do you know what cone is? Like an ice cream cone? Yeah. Cone. So what we do is we take two cones, and this is supposed to be like a 3D shape here, and they meet kind of at their vertices there at the pointy bit. And we take a section. The section just means a cut. So if I were to like just slice through at this angle here, I get a shape like this. And this shape is called a parabola. And this is what we're going to be spending a lot of time looking at in this unit, parabola. You can also cut straight across. And think about looking down at a cone. This is a circle shape. You'll see a lot of these in geometry. If you were to cut just a little bit sideways, your circle kind of turns into a squishy circle, or an oval. Those are called ellipses. In front of the White House, there's an ellipse, right? They talk about the ellipse in front of the White House. No, you never heard of that? It's like a street. Oh, yeah. They call it over the ellipse, president, whatever. That's this shape. We learned about these. We used to do it in algebra, so we aren't thinking about it now. I'm thinking that's where they do that. Hyperbola. This one I take the cut and it's between both cones. Between both. So you have like a shape here and a shape here, and they're together. And we're going to actually be looking at this a little. And you'll get more of it in again concept. But we'll see that one a little bit. So for us, this one and a little bit of this one. But for now, mostly we're going to focus on that guy. But this is where they come from, conic section. So a parabola is that shape, this kind of thing. And there's different pieces to it. So we're going to kind of talk a little bit about the different pieces. This is what I got here. Standard form. Does this look familiar? Ax squared plus bx plus c. Yeah. Right? We've been factoring these things like crazy. Yeah. What? Or 3. So we've been learning factoring for a purpose. So, and we're going to find out today why we've been learning factoring. So this is standard form. If you see something that looks like this, it's going to graph to a parabola. Parent function. This is kind of like you start with this, and then you work around this, and you get other parabolas. We're going to focus on this a little bit more later. But it's called the parent function. Y equals x squared. A is 1 and B is 0. A vertex is the lowest or highest point. Well, first of all, what do you mean by lowest? Where's the vertex on this guy? 0, 0. Do I go below that at all? No. Does it have a highest? No. Given that these are arrows? No. So it has what we call a minimum value. We also call this value the turning point, because here I am, look at this, going down, whoop, turn, going up. So the vertex is also called the turning point. Now if you're reading this, it says the lowest or the highest point. Sometimes a parabola will look like this. So this one doesn't have a lowest point, but it has a highest point. We call that the maximum. So this one has a minimum, and this one has a maximum. Both these areas here are called the vertex. Both of them are turning points. You see I'm going up, going down. Where I turn. So a little bit of vocabulary there. The axis of symmetry. That is the place, it's a line, and it splits the parabola into kind of two what we call symmetric pieces. Do you know what that means? Symmetric? What is that? What? It's the same on both sides. Some people say our faces are symmetric because if you can kind of draw a line, down the center of your face, is it? Listen, it's close enough. Well, not close enough for this example. Not really though. But a symmetry is the mirror image, right? One side to the other, mirror image. Yes. Well, then you are asymmetrical. What? Not symmetric. But these are symmetric. And you can think of folding the paper along the axis of symmetry. This side is going to fold exactly on top of that side. That's symmetry. Axis of symmetry, line of symmetry. Alrighty, what else do we know? This idea of concavity. I had no concavities at the dentist last time I went. Sorry. I'll go there. It's got nothing to do with holding your teeth. Concavity. We talk about whether a curve is concave up or concave down. A concave up parabola one that looks like this. They call it the smile. Looks a little like a smile. If you were to pour water into it, it would hold water, right? Like a cup. Concave down is the other way. It's the frowny. So if you were to pour water on, it's like an umbrella. It deflects. So up is the smile, down is the frown. That's not the best example, but it helps me remember it. It occurs when A is positive. What A? Remember standard form? AX squared plus BX plus C. If this A is a positive number, you are concave up. There's all kinds of work. It works here. You smile if you are positive, and you are up, and you are negative if you're frowning and down. So concave up, positive, concave down, negative. When you are concave up, you have a minimum value, and when you're concave down, you have a maximum value. All this should hopefully just make common sense. Okay? Think about what they look like and all those things that you share. Let's, I hope you have graphing calculators. If you don't, just hang tight, hang tight. We'll look at mine. I'll look at one in a moment here. So, I want to work on the graphing calculator just a tiny bit. So, you go to y equals. So just watch up here if you don't have one. If you do have one, just press the button. I've got to put it in first. I'm going to do a second plus 712. You may want to do it as well just to clear out the calculator in case they didn't do it before we got there. So y equals x squared. So if you remember how to get there, if you look at the alpha button, look one to the right, there's your x. Your square button is near the 7. It's up and left. And let's graph this. Y equals x squared. Is this what we expected? Because what is the concavity of this thing? So it is concave up. What is A on this one? Negative. This one we expect to be concave down.
What is wrong? Wait, it's not expect to be there.
Well, it will because it's math. We don't state anything in math unless it's true. Math is one of those things you can count. That's why we like it. See what I did there? All right, I'm going to take this a negative x squared. And what do we expect it to look like? Frowny. It is frowny. So it tells us which way. And if I give you this and I said, gee, what is A? Is it going to be positive or negative? Looking at this, what would you say? Negative. So you can go back and forth with it. The calculator is your friend with this. So that's one thing. Transformations. Now, a moment ago I mentioned this idea of y equals x squared being a parent function. When we graph quadratics, we take advantage of transformations. Now, do you remember transformations from way back? What's a transformation? We had different kinds? Do you remember them? Yeah.
It's that thing on the graph was like
It is that thing. So what are you doing here? Slide. Slide. Reflect. Rotate, right?
Yeah.
There was another one called, you have something very small and you enlarge it. Dilation. So when we work with graphing, transformations can actually help us. So dilations actually occur with transformation. So if you have y equals ax squared plus bx plus c. If this a, just looking at it as a positive number now, if it's bigger than 1, and I put the absolute value in, so even if that's a negative, but if the number itself is bigger than 1, what happens is you get a very narrow parabola. I'm going to look at some shapes here. So I'm going to go back in my y equals, and I'm going to just graph the parent function, which is y equals x squared. And then I'm going to put y equals 4x squared in. Whoops, that's the wrong button, because I can't really do it there. Okay. So x squared is going to graph first, and then you're going to see y equals 4x squared. There's x squared. Here's 4x squared. What happened? It got thinner. And we call this a stretch. Because what happened, it was as if I took, like, if these were two strings, and I kind of just pulled on them a little bit. It pulled them tighter. So I stretched it up. So that's a dilation shape. Gives me an idea what happened. Now what happens if a is less than 1, and what I mean here, it's a number between -1 and 1. That means a fraction, right? What if it's a half? What if it's something to get kind of wider. So I'm also going to graph this guy, because here on my A is now between -1 and 1. So let me put that one in as well. Now how do you put a fraction in here? Don't try to convert it. Just put a parenthesis, 1 divided by 4, and close the parenthesis, and then put in your x squared. Don't convert it to a decimal. Let the calculator take care of that. Here it comes, here it comes. So it gets very wide. This is a compression. It's like I squashed this. I took x squared and I squashed it a little bit. So I transformed it using evaluation. So if you have a big number here, you get a very skinny one. If you have a fraction here, less than 1 or greater than -1, it's going to be a squishy one, compressed. So again, it helps me just get an idea of what they look like. The other kinds of transformations we're going to look for is if I add a constant. If I add a constant to it, you start with your parent function and add a number. Let's try it. Let's try it and see what it does. So I'm going to go back into y equal. I'm going to leave my x squared. And I'm going to type in x squared plus 3. X squared plus 3. Right? Yeah, oh, speaking ahead here. I'm going to graph this. The first one you're going to see is x squared, and then you're going to see x squared plus 3. So here's x squared. What happened? Shorter? What do you mean by got shorter? Now remember, this is still going. I don't see it.
It did go over 6. It got raised higher.
It got raised higher. That's exactly what happened. How many units higher? 3. So this raised it higher. Now what do you think is going to happen if I subtract 4 from x squared? It's going to get lower. And these are called translation slides. So x squared minus 4. There it goes. Moving it down. So transformations also help me get an idea what they look like. So if I change this c, and it's a positive number, I'm adding a number to it. The graph moves up or down. When you add something to it. When you see it negative, I'm subtracting. The graph moves down. And these are translations, meaning they're just slides. You're taking x squared and you're just sliding it down. I don't know. I kind of have it on here. It's under transformations. In there. It kind of just says it for you. If you want to write a note x squared, you can. But that's just to remember. And why is that helpful? It gives me a sense of what they look like. Just like we need a number sense, we need a graphing sense as well. So when I see this, I can immediately sketch that. It's x squared up 3. And when I see this one, it's x squared minus 4. I take my x squared and I just pull it down. It's a way to quickly sketch what they look like. Oops, that's a horrible looking graph, but it's graphing sense. That's graphing. Okay? Now how do we graph them? We're going to look at 3 different ways to graph them. 3 different ways. To manually graph it, meaning you're sitting with a pencil and paper. The first way is the table of values. And the table of values method is one we reviewed during the warm-up. Exactly the same process. Exactly the same. So on the bottom of your page 1, this is where we are here. It says sketch y equals x squared minus 3x plus 1 using the table of values method. So you make a table of values. You put in some sample values from your domain. And how am I going to find the y values? Plug it in, right? Isn't that what we did with the linear? It's the same process, right? If x is -2, I have to put it in 2 different places though. Because I've got -2 squared. Here's another x, so I have to plug it in there, plus 1. So is this plugged in correctly, right? Notice how I put parentheses here? You always want to put the parentheses around the x value. Because now let's see. If I've got -2 in parentheses and I square it, what do I get? 4. Yay. Now I've got a negative times a negative. Positive, so that's 4 plus 6 plus 1. Now, if this is difficult, and believe me, I make mistakes doing this too. Who's my friend? You can, as long as you put these parentheses in, just type exactly what you see. -2 squared, where's minus 3 times -2 plus 1. And you can let the calculator do this for you? Why not?
25.
Well, something bad happened. Did you put the parentheses in the correct spot? These are
I got 11.
extremely important that
You
you
want to
put
put
the
the square
parentheses.
inside. No, that's what I did.
Well, I don't know what to tell you. I'm thinking it's not. Now with negative, let's put negative 1 in, right? So this takes just a little more work than it was for linear. That's 1 plus 3, 5. Zero's our friend, it's easy. Plug 0 and 0 in, you just take this guy, on. Just like with line, right? The x value is 0, you can just take the constant. 1, plug 1 in, that's 1 squared. Minus 3 times 1 plus 1. 1 minus 3 is negative 2 plus 1. And let's plug 2 in. 2 squared minus 3 times 2 plus 1. 2 squared is 4. 4 minus 6, right? That's negative 2 plus 1. Wait a minute. I got another negative 1. But did I make a mistake?
No, the bottom is looking at 1.
Oh, well, let's graph this guy. What's going on here? So I've got a negative 2, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, up here someplace. Then I go to negative 1, 5. 1, 2, 3, 4, 5, 0, 1, 1, negative 1, 2, negative 1. Let me put another point in. If I have a 3 here, that's 3 squared. 9 minus 3 times 3 plus 1, right? So I got another 1. What do you think the value is going to be if I put in 4?
5.
Why 5? Without even doing the calculate, why 5? You see what's happening here? What do you think it's going to be if I put a 5 for x? It is symmetrical. You're absolutely right. The symmetric shape of these says once you start seeing it turning, I can see what's going to happen to the next one. So here is my parabola using a table of values. Now the one problem I'm having with these, I mean, it's really good. The pro is you already know how to do this. We've done it with the line. That's good. It's easy, other than maybe you might get a little calculation mistake here. What's the con? This vertex, is it here? Is it here? I don't know the exact value of the vertex. I don't know exactly where it's from. Unless I happen to guess exactly the right x to try, that's a little bit hard. But the table of value method, listen, always keep that in your back pocket. It's a nice little method. Any graph that you get, you can use the table of values method. Come up with some x's, plug it in, see what the y's are. So that's one method. But let's look at another method, which is using the properties that we can figure out about the parabolas. So, concavity zeros, find these values and sketch this. So this is a new formula. We have not seen this yet. Remember our axis of symmetry? So if you've got a parabola, I'm not going to go to the upper on it. That centerpiece is your axis of symmetry, pretend it's symmetric. You can actually find the equation of this line. Let's say that word again. It's a line. Now, it's a vertical line, is it not?
Yeah.
How do you write the equation of a vertical line? Vertical.
X
Equals a number. Nice. What is it? Y equals a number? This is what kind of line? Horizontal. So I don't want that one. So x equals. This is important. It's a line. I better see that x equals. And here's a formula to find what the number is. Now what? That refers to ax squared plus bx plus c. So you find the a value, find the b value, negative b over 2a. Will give you x equals a number, where it goes. And I'll show you that in a moment. So that's how you find that. Now the vertex. Some people freak out when they see that. What's going on here?
Oh no.
Now here's the vertex. Relax. If I have a parabola around an axis of symmetry, right? It's over here. Isn't the vertex always on that place that if you fold the paper, we're going to meet up? Here. So its x value is always going to be the x value on the axis of symmetry. And now I'm looking around. All right. Let's say this is x equals 2. Is this point on here. What's its x value? 2. Exactly. So the x value of the vertex is always whatever you got here. It's negative b over 2a. If I know the x value, how do I find the y value? If f of x is, I'm making up anything here. I'm making this up. Making it up. In fact, I'm going to make it do this. So if my axis of symmetry is at x equals 2, how do I find the vertex? I know the x value is 2. How do I find the y? How do I find the y? If I know the x? Plug it in. I heard it. Who said plug it in? Plug it in where? How do I do this, Claire? Yeah, just like we have a little table. We just did this, right? The 2 goes here, plug it in, you find the y. That's what I mean by f of negative b of 2a. You're going to find f of 2, right? Because that means plug 2 in. So if this is like, please stop this, make it go away. The vertex, the x value is this, and the y value is plug it in. Alrighty. Or here's the third way, the graphing calculator. So we're going to use all 3 methods. We did this one already. Let's look at how to graph. So I'm now on the back here. We're looking at graphing f of x is x squared minus 6x plus 5, right? I'm on page 2 top. So we're going to consider different things. However, the first thing you want to do, it's not written here, is you want to find a, you want to find b, and you want to find c. Looking at this guy, remembering that y equals ax squared plus bx plus c, what's a? Remember, it's the biggest one. Yeah, it's invisible here, but it's 1. What's b? And what's c? So I'm going to need that information. Now I'm going to look and decide, is it concave up or concave down? Why is it concave up? Leading numbers positive. It's going to look like this. It's a smile. Y-intercept. I'm saying this note here to see. First of all, y-intercept. That's going to live on here someplace, right? Same y-intercept. What's the x value for y-intercept? What's the y-intercept? I'm sorry, x value for y-intercept? 0. So you're going to plug 0 in, plug 0 in. That's why the value is always what c is. Because when you plug 0 in, you're just going to get the constant up. Now go ahead and graph that, sure, why not? This is part of the graph. You have a y-intercept of 5. Alright, you got 1 point in. Alright, now, axis of symmetry. X equals negative b over 2a. If you forget the x equal, prepare to get the question wrong. Because this is a line. And if you just give me a number, you are not giving me the equation of a line. That x equal is really important. Let's find out what this number is. Negative b. So negative, what's b? Negative 6, right, negative, over 2 times a, and a is 1. So substituting in, negative negative is a positive, always simplest form. So it's x equals 3. X equals 3, not 3. You write 3 here, 3 wrong. X equals 3, it needs to be a line, not a point, not a number.
So, will the b always be negative?
No.
What's not?
And what if I have a different function? Plug it in. Well, there's always a negative here, and then you put b here, whether it's positive or negative. The formula is negative b over 2a.
Oh.
So if b is negative, a positive will come out. If b is positive, it will be negative. But then a matters too. All right, so x equals 3. What does x equal 3 look like?
The line with the line.
It's a line, what kind of line? Vertical line that goes through x equals 3. 1, 2, 3. Now I'm using dashes here because it's not part of my graph. It's not part of the function. It's a guideline. It's going to help me do the graphing. Now I've got symmetry, right? And I got 1 point on this side. So if I fold the paper here, what am I going to see on the other side? A matching point. So this one's 3 away. This one's also going to be 3 away. I got 2 points now. Just like that. Now I have to find the vertex. The vertex is my turning point. This is where you're folding your paper. You're always going to have your vertex where you fold the paper, right? It's down, whoop, now it's up. That's where your turning point is. So what is the x value of the vertex? 3. Because it's on the axis of symmetry, and every point on the axis of symmetry has an x of 3. If I know the x is 3, how do I find its matching y value? Plug it in to this. Right? It's like having a little mini xy table. That's 3, so I'm going to do 3 squared minus 6 times 3 plus 5. That's 9 minus 18. Negative 9 plus 5. There we go. 3 negative 4. So I'm at 3. 1, 2, 3, 4. Now I know this is concave up, right? And concave up. So can I see what's happening here? I'm going to have something like this. There it is. I'm getting very close to my sketch. The only thing I wish I knew was where it's going to cut through the x-axis, right? How many zeros will this function have? How many? 2. How come? Coming up, right? Coming up. Now I don't know exactly where it hits, but I know I'm going to have 2 of them. So I'm so glad that we all know how to find the zeros of a function. Remember how to find the zeros of a function? Here's my function. I want you to find the zeros. What's the first step? Set f of x equal to 0. Look at you guys. Oh, doing this big boy, big girl math. Look at you. You set it equal to 0. Okay? What? Factor it, right?
Oh, no.
Oh, yeah. No, it's not going away. No. This is a type 3. I need 2 numbers that multiply to 5 that add to negative 6. Negative 5 and negative 1. For type 3, a lot of you guys are busy doing the whole splitting it up, and again, not wrong, but this is all you had to do. To say, you're splitting up and you group factor. You can. Don't get me wrong, you can. But you were making your life really difficult. All right, now, what? Yeah. I have to find x. Right? I have to find x. What? How hard was this, Alan? Okay. Now, how do I find, what do I do? You said each factor equal to 0. Remember that? So what's x? 5 and 1. Now what? I found the zeros. I'm just putting them in order here. You can say 5 and 1. That's okay. What does that mean? Over on the x-axis at 1 and 5, I got some zeros. And they should be symmetric to that, the axis of symmetry. They are. And now I can see my sketch a little bit better. I'm going to sketch. Connect the lines. No fuss, no fuss. And I think that's how you go. Using this second method. Let me see. So let's see. What did I want to say here? The other thing you can do, let's use the graphing calculator. And I'm going to graph it. And I want to see how we did. So let's see, x squared. X squared, that's typing it in. Minus 6x. Plus 5, let's graph it. And I did the wrong button! Okay, x squared. I'm sorry, this is not my day. Minus 6. Anybody else having a hard day after that? Just wait. It's Friday though. Alright, looking pretty good. Can I at least, let's see, we have about 2-3 minutes. Perfect. How do I know I got the right values here? I'll tell you the zeros or the vertex. Table's one way, but then I have to find it. Now, what can I do? Look at calc. See calc? Remember calc? See your trace button? Look up one. See word calc? Same color as your second button. Press second and trace. Do you want to find the zeros first? See if they work? Yeah. So press number 2, 0. And you're going to look for the little blinky guy. I'm going to look for this 0 first. You can only find 1 0 at a time. And it's saying left bound. So here's the 0. I want my little blinker to be a little bit to the left. Once it's a little bit to the left, press enter. Then it says right bound. Use this little arrow key until you're a little bit to the right of that 0. Then press enter. When it says yes, press enter. saying I've got a 0, 1, 0. Isn't that what we found?
Yeah.
Yeah. Let's find the other. If you get no sign change, you're probably going to go left or right. Let me try the other 0.
How do you do this?
Have you all in here? You press second count. Now I'm going to find the other 0. So you're going to press 2 again to find the 0. This time I'm looking for this one. Left down. Move this guy until I'm a little bit to the left. If you get too close, you will get an error. So, this should be okay. Now do it right down here. I'm doing this one. There it is. Moving it, moving it, moving it, moving it. Right, now to the right of the 0. And then when it says yes, press enter. 5. And this is a negative 12 again. That's 0 essentially, right? It's scientific notation. 1 times 10 to the minus 12. Virtually 0. This algorithm is just taking a little longer. So we found it. And when we come back to lunch, we'll look at how you find a vertex. We were using the calculator, so we looked at the calculator to find the zeros. I want to show you how to use the calculator to find the vertex. So we have to decide looking at this. Here's my vertex, right? What were the different names for vertex? What? Oh, what? Just looking it up. Yeah, what is it? Turning point, and
Minimum and maximum.
minimum, maximum. Is this one a minimum or a maximum? Looking at it.
Minimum.
Minimum, right? It doesn't get any lower than that. So you go to that second trace button, the calc button, and I want to find the vertex. What do you think I should select? Minimum. Whoops, oh, that doesn't work. Minimum. Right? I want to find the minimum. And this works the same way. It says left down. Okay, so I'm looking for this value right here, right? So you go to, aren't I? I want the vertex. The minimum. So left down says go to the left of it a little bit. See where it's linking right there? So I'm doing that. Then it says go to the right down. So you're going to the right of the point you are interested in finding. Until it says right down. Then when you find you're at the right, you hit enter. When it says yes, you hit enter. Oh. And it's doing its best. It has like a little algorithm to figure this out. But look, isn't that 3 negative 4? Yeah. So we got so the error. So the calculator can find all these things for you. Great. Let's try another example here. This one, it's example A, middle of the page there. So write out A equals B equals C equals. What's A? Negative 1. What's B? And what's C? Is it concave up or concave down? Negative A means it's down into front. What is the y-intercept? Axis of symmetry. X equal. Are you going to forget to write x equal? No. X equal, you're writing the equation of a line now. So I need x equal negative b over 2a. So it's going to be negative, what's b's value? 6 over 2 times, now a is negative 1. So now I've got a negative 6 over a negative 2, which is 3 again. 3. X equals 3. So x equals 3, go ahead and sketch that in. That's a vertical line. Goes through x equals 3. And I'm just doing dashes here because it's not a hard line, it's a guideline. Just to help me graph. So I put that in there, and I forgot to put my y-intercept in. I'm going to put that into 1, 2, 5. Let's go. 1, 2, 3, 4, 5, 6, 7, 8. Because I know my axis of symmetry, I've got another point on the other side. 1, 2, 3. Did I miss? Where's the 1, 2, 3. I missed for x equals 3. Yes?
Why did you put
That's the axis of symmetry. Remember what that thing is? Yeah, I know, because I can't really see. I'm like back here and I totalized. So I'm fixing it. So I'm just going to concave down, right? So something like this. Maybe it's up here, but I'm getting some sense of its shape. Now, how am I going to find the vertex? What's the x value? 3. Same thing as that. Then how do I find the y value? Plug it in. Because x equals 3, Here's my axis of symmetry, and it's going to be on there. Plus 6 times 3 minus 8. Now what's this value? This is 3 squared, take the negative.
Negative 9.
Negative 9 minus 8, is that 1? Now again, use this guy for like, I'm not sure. So you just type it exactly with those parentheses.
So why are you doing 3?
Why am I doing 3? You tell me. Why am I doing 3? The axis of symmetry is x equals 3. The vertex is on the axis of symmetry. There we go. If you have trouble, use this thing. Okay, so vertex is at 3, 1. So 1, 2, 3, 1. Getting a sense of what this is looking like. How many zeros will it have? 2. Right? There's something in here and something in here. Let's find out exactly how do you find the zeros of a function. Take the function, set it equal to 0, and then factor. A lot of people got this factor wrong on the test. You could do this like a type 5. I think it's easier to take out the negative. If I take out the negative, especially in the factoring section, people just throw it away. It's right here. And then I reverse all my signs, but I can get back to my original. You always should be able to get back to the original when you're doing strict factoring. So now I'm going to leave that guy here. It's a type 3 inside there. So x and x. 2 numbers, multiply 8. But add to the negative 6 here. Which one? Oh, that's a good question. We'll get to that one. That's a very good question. Okay, so now we said each one of these equals to 0. So x is going to be 4 and 2. Just turning it around here. It's okay. Just say 4 and 2. So 1, 2, 3, 4. And I can see a little bit better now. Something like that. And that's using this guy. Let's try another example. Shall we? Any questions on this guy? Yes.
With the 3 dots at the top, what is the graph? Maybe 1, 2, 4.
What's that? What? Yes. This is the vertex, and these are the zeros. And these were just because I found the y-intercept, I found it symmetrical on the other side. Another example of x squared minus 1. So a equals b equals c equals what's a? A1. What's b? 0. And what's c? We need to back up. Why is this thing 0? Right? The x term is missing. The only way it's missing is if b is 0. Alright, so my concave up or down? Up, so I'm being a smile. Y-intercept? Negative 1. Axis of symmetry. X equals negative b over 2a equals negative 0 over 2 times 1. Well, what's that? Zero. When are things undefined if you're dividing by 0? I can have a 0 in the numerator. That's 0. So, well, how do you graph x equals 0? You do. How do you graph x equals? You sure you do?
It's just in the middle.
It's the y-axis. Yeah. It's the y-axis. Isn't that x equals 0? Isn't that where x equals 0? That's right here. And then what's your vertex? Negative 1 with a negative 1. Alright, I already knew I had a point at 0, 1 because I knew my y. Because plug in 0 for x, what do you get? Yeah? Now this is a concave up, right? How many zeros will I have? Just looking at it. 2, because it's going to cross twice on its way up. So let's find what they are. So x squared minus 1, when does that equal 0? Perfect square minus perfect square. Right? Take the square root of this, that's type 2. Take the square root of that guy, plus minus. So x equals negative 1 from this one, or x equals 1. Now I put them on here. Here's my y-intercept. Now with ones like this, because I don't really have a y-intercept separate from that, I tend to do maybe 1 or 2 points using the table of values. Let's see what happens when x is 2. So 2 squared is 4, minus 1 is 3. This is symmetric, right? So what's negative 2 going to be? It's also going to be 3. And I feel a little bit better now about the shape. So sometimes you may want to use a table of values if you're having a little trouble seeing what the shape is. Yes?
I'm confusing how to equal
The vertex?
Yeah.
Are you okay with how I got the axis of symmetry?
Yeah.
Okay, this x equals 0 will always be the x value of your vertex because the vertex is on that line. And then you take the 0 and you plug it into the equation where x is. So if you put a 0 in here, 0 minus 1 is minus 1. Okay?
How do you put it?
Now this one? These two?
Yeah, like on the graph, how do you get like?
Oh, this? Alright, now you saw when I put 2 in, you get how I got 3. I plugged the 2 in here, I got 4 minus 1. So that's this one. The axis of symmetry says everything that's on one side will have a match on the other. So in the exact but opposite position. So this one is 2 away from it. So 2 away from it, I'm going to have another point. You could have said plug in -2. You get the same value. Alright, so there that is. Now remember we talked a little bit about transformation? X squared minus 1. If we think of our parent function, y equals x squared, what does x squared minus 1 do to it? What does the minus 1 do? Moves it down here. Isn't that what we got? So, again, you're trying to get as many different ways to think about what it looks like as you can. So good. Let's try this one, x squared plus 2. So let's do a equals, b equals, c equals what's a?
1,
b?
0,
c? Alright, concave up or down.
Oh,
Let's get routine already. What are you guys? Y-intercept. Put that on here.
What's it?
0.
X equals negative b over 2a equals negative 0 over 2a. That's 0, so x equals 0. So again, we're on the y-axis. I'm a little trouble missing and missing. Vertex, 0, 2. What's this? And it's a concave up, right? So it's going to be up here. Concave up, it's the up.
How do you get the 0?
How do I get the 0? Well, that's a good question. So if this is where my graph is, right? It's concave up. Are there any zeros? No.
No, how do you get from the vertex? How do you get the 0?
Because x equals 0. This, that, whatever, negative b over 2a, that's going to be the x value of your vertex. Always. Then I put the 0 in, I got 2.
So on the last one with the negative, with the 0, -1.
Wait, question? Like, why is there no zeros?
Yeah.
Alright, I don't know what this looks like, but I know it's concave up. It goes to this point. This is probably not what it looks like, but is it going to hit the x-axis? And there are no zeros. So when this happens, you just make a little table of values, and just to find a couple of points. So let's try 1. 1 squared is 1 plus 2 is 3. 1, 2, 3. So what's going to happen on the other side? Going to have a match. How about 2? 2 squared is 4 plus 2. Up here, and I'm going to have a match on the other side. That's probably enough. Just to get an idea of the shape. Yes?
How did you get the 0 to the vertex anymore?
How? I take the 0 and you plug it into the function. Right? If you're given an x value, how do you ever find a y value? You plug it into the equation. And again, think about transformations again. If you're starting with x squared, whoops, that's meant to touch here, alright, it's not a good drawing. X squared plus 2 means what? Move it up 2. That's what that means. So they do. So again, if you kind of have an idea of all these different ways to graph, you get a sense of what they look like even before you go into this. You're just learning, so it's going to take you, it'll take a while. Let's do the calculator one more time. We kind of did this one, but let's say I gave you this problem, and you just want to use the calculator to get all these values. So what you do is you go to y equals, first you turn it on, and you plug in your, graph. Negative x squared, all kinds of trouble to do things. Negative x squared, well, I'm doing this one right here, plus 6x minus 8. So I'm just, here's the problem. Graph it, up the calculator. Just you can. So I'm going to go ahead and hit there. What's the concavity? Just by looking at it, down. So you calculate really your friend with this thing? Huh?
No.
It's not on here? Oh, it's on the board. We're just doing it on the board. Y-intercept is probably easier just looking at it. It's -8. Now, how am I going to find the vertex? Let's review what we do. The vertex, where is that? That's this, right? How am I going to find its value? Is it a maximum or a minimum? It's as big as we get, right? It's a maximum. So you're going to hit the calc function. And what are we going to hit? Number 4 to find the maximum. And it says left down. I'm pressing this little arrow until I get to the left. No, it doesn't have to be very far left. To the left of my vertex. When you find a good spot, press enter. Right down. I'm going to move this little guy to the right of my vertex. And then I'm going to press enter. When it says yes, I'm not going to. I'm pressing enter. Thinking. 3, 1. And then, 1, 2, 3, what? Where'd you lose me?
Oh, okay.
What happened? You okay?
Yeah.
All right, now we need to find zeros, and I'm going to use again the calculator to help me find the zeros. So I press that calc thing again, second trace button to get the calc. I'm finding zeros. What do I want? Number 2, this guy right here. Find the zeros. You can only find 1 zero at a time. What? Well, let me get there. So let's say I'm working on this one. Left down means go to the left of it. I'm going to the left of it. Make sure you're really good left of it. It gets mad sometimes. So here's to the left of it. Then it says right down. So go to the right of it. This is how the calculator knows which zero you want. 2, 0. So I got 1 at 2, 0. Well, you went to the other one, I think. I did this 0. Now I'm going to do this 0. So I'm going to hit second calc number 2. Find the other 0. Now I'm working on this one. Maybe you did the other one first. So now I'm going to the left of this guy, hitting the enter. I'm moving to the right of it. I'm hitting enter. I'm hitting enter. The other one's at 4, 0. Yes, ma'am. How would I find the axis of symmetry? That's an excellent question. Using this thing here, how am I going to find the axis of symmetry? I know it's x equals something. Right? What is it? X equals 3. How come? It's this value. So you can get everything with just the calculator. I shouldn't even tell you. It's all I'm going to see, right? So you go to 2, you go to 4, where my zeros are. For one like this, oh wait, I know it's -8, right? 1, 2, 8. And I can draw in my axis of symmetry. And this is what, 1, 2, 3. So I want 1, 2, 3. I'm looking this way. So you can, the calculator is your big friend with this. It really is. Yes? Well, didn't we just do that whole thing with velocity and falling objects and it looks like a problem. I'm throwing a ball. So yeah, it's like it can be distance, it can be a lot of different things. Now, this one we actually do use in real life. We do. Okay, so that's great. Can you just use the calculator and forget the other stuff? No. But knowing how to do both ways, right? So you can certainly verify the manual method of this. So now it's up to you to retry. So here's my suggestion. Find A first, find B first, find C first, fill in the values. You're doing this now, manual method. And you can verify it with the calculator. Also things you need to know, axis of symmetry, x equals -b over 2a. Do you have a question? Yes, you can sometimes have an axis of symmetry that's a fraction. It happens a lot, actually. So let me do that part. So you got x equals, it's a little ahead of us, so he's working ahead. X equals -b over 2a. So what's a?
1.
What's b? And what's c? Is it up or down? What's the y-intercept? All right, so -b, so -1 over 2 times 1, that's a a 1/2, right? So my vertex is now 1/2, comma, you know, you can plug all these in and work with it. It's not so bad. Oh, you'll love this calculator. Just something. Let's practice how I would use the calculator to plug in these points now. So you can type in a half, you put in a parenthesis, 1 divided by 2, close it. That's a half. I want to square it. And then I'm subtracting, whoops, wrong thing. Minus 1/2. And then minus 2.
That's negative 2.1.
So negative 2.25. Wait, you could put that in here. The reason I'm not is because I can't help it. If I see a fraction, I want a fraction. So how can I turn this easily into a fraction? Math button, where that little fraction is, press frac. It's negative 9/4. Now this is nice to have, because I have to graph this thing. So you go to 1/2, and then the 2.25. Over here. Yeah, yes, right? If you have an x value, how do you find the y value? You take the x value and you plug it in. Is that right? Oh, wait, I went the wrong place. I did something not right. What did I do? Why did I do this? Incorrect. I did something wrong. What? How did I get the 0? What?
On the y-axis. Yeah, put a dot on the y-axis.
Y-intercept. Right? You plug in 0. Oh, vertex. Okay, I see what I'm doing. I don't know what I'm doing wrong. I'm doing something way wrong and I can't figure out what it is.
Put the axis of symmetry.
I did put the axis of symmetry in. So this goes. No, that's actually correct. And then this, it's just not a very deep one, right? This goes over here someplace. It's still concave up. Right? And now it's going to have 2 zeros. I can see that. How do you find the zeros? Plug in. You're not going to plug in. You got to do some factoring, my friend. Okay? X. Two numbers that multiply to negative 2, but add to negative 1. All 2 and 1. This got to be negative, this got to be positive. So when x minus 2 equals 0, when x equals 2, so when x equals negative 1, so I go to negative 1, I go to 2. Yes, absolutely. This is what you have to know to do. Sure. All right, so I did one of the u-tries. It looks like it's your turn. Be careful with this because what's big? 0. Okay? What's that? 1. Alright, you try it now. This is you try now. Okay, if you got that, that's great. I'm going to put the answers over the other one just so it's here. You can try it at home. This is what you should get for the third one. Oh, it's not what you got. So you're going to have to